Okay, so I'm going to be taking this equation, which is currently in vertex form. Remember, vertex form is y equals a, and then in brackets x minus h squared plus k. So in this case, my h is 2 and my k is 6, so my vertex is 2, 6. And I want to go and change it into standard form. I'm going to follow BEDMAS. So according to BEDMAS, the first thing I'm going to do is exponents. So if it helps, you can write this as this. So when you are squaring something, it means you're multiplying it by itself twice. Notice that I'm only doing that for the x minus 2 because that's what has an exponent of 2. The 3 is on its own, and according to BEDMAS, I'm going to do multiplication later. I'm first doing exponents. So I need to multiply this out. Remember, expanding binomials is kind of like doing the distributive property twice. I'm going to do the distributive property with x, and then I'm going to do the distributive property with the negative 2. So that'll give me x times x is x squared. X times negative 2 is negative 2x. And then I'm going to multiply by the negative 2. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4 plus 6. Okay, now I can simplify what's inside the brackets. So I'm going to add the like terms, which are negative 2 and negative 2. Everything else stays the same. No more like terms here, so the next step is to multiply by the 3 that's outside of the brackets. So I'm going to do the distributive property with the 3, which gives me 3x squared minus 3 times negative 4 is negative 12x. 3 times 4 is 12 plus 6. I don't even need the brackets. The only like terms left are the 12 and the 6, so I'm going to add them together. And that's it. It's in standard form. Okay. The second strategy to doing this is you will notice that I ended up with the same term twice here, negative 2x and negative 2x. That is always going to happen. And the reason for that goes back to the idea of perfect square trinomials, because this here is what a perfect square trinomial looks like when it's factored. Here it's in expanded form. So I'm going to show you a second way of doing it, thinking about perfect square trinomials. For some of you, if you need to write this out, that's okay. This is just a strategy to make it faster, to skip these steps right here. So I'm keeping in mind perfect square trinomials tell us that if I have two numbers that are squared, their middle term is going to be double the bases multiplied. So this is kind of like going backwards. From this step here, I'm going back to this. So when I expand x minus 2 squared, I get 3. So in order to go from this step to this step, I take this first number and I square it. So x squared, this is a minus sign, so minus 2 times x times 2, and then I'm going to square the b. So negative 2 squared is plus 4. So this is kind of like working backwards, going before we went from this step here, now we're going from this step backwards. And it makes it faster because eventually you'll be able to do this part in your head. So that equals 3x squared. 2 times x times 2 is minus 4x plus 4 plus 6. And then I continue from there. But this step here, it leads me back to the same step. This step here and this step here are the same. So this is kind of like a shortcut. Okay, so I'm gonna simplify this using the shortcut. So the question is y equals 1 over 2, and then in brackets x plus 4 squared plus 5. So I'm going to keep this outside the brackets. So I square the first number plus 2 times the bases, and then I square the second number. Okay, I'm going to simplify. 1 over 2, and then in brackets x squared plus 2 times x times 4 is 8x plus 16 plus 5. Okay, so the next step is to use the distributive property with the half. If you want to change it to a decimal, you can do that. Half times 8x is 4x. Half times 16 is 8. And the like terms are the 8 and the 5. So I'm going to add the like terms. And now I have standard form.